Ali.
Walaikum salam. Good afternoon.
Uh,
Hope you can hear me now. Can you hear me
yes, I'm
clearly?
ready.
Okay, that's good. Can you see my screen? Can you see my screen?
Yes.
Mashallah. So, what do I have on my screen? Smart Maths Academy Holiday Challenge, right? Hope you can
He's
see
in
it.
class. He's in class.
So now, you are welcome to today's class. So our today's topic is longitude and latitude. So we move to the next slide. So this is the next slide. So longitude and latitude is the topic for today. So and I define meridian of longitude or lines of longitude are imaginary lines that run in a north to south direction from the North Pole to the South Pole. So let me take that again. You can define line of longitude or longitude. So if it were to be one, so you define longitude as imaginary line that runs from the North Pole up to the South Pole. But since we have many lines of longitude, that's why we have meridian of longitude. So are imaginary lines that run in a north to south direction from the North Pole to the South Pole. So I will show the diagrammatic representation of this. So they are measured in degrees. So the unit of longitude is what? Degree. So meridian of longitude are halves of great circle that connect one pole to the other. So what are the pole under consideration? They are the North Pole and the South Pole. So we use the line of longitude to connect the North Pole to the South Pole. So that's the definition of the longitude. Then the second one is the lines of latitude. So are imaginary lines which run in an east to west direction around the world. So longitude, latitude runs from the east to west. That is the horizontal. So they are also called the parallels of latitude. So because, okay, they are also called the lines of parallels of latitude. So that's all. So they are also called the lines of they are also called the parallels of latitude. So that's all. So now, latitude are measured in degrees as well. So latitude are also measured in degree. So just like longitude. Longitude also measured in degrees, while the latitude also measured in degrees. So I'm just doing some adjustment there. So this is definition of longitude and latitude. So according to this note now, longitude is an imaginary line that runs from the North Pole up to the South Pole, and it is measured in degree, while the latitude is imaginary line that runs from the east to west, and it is also measured in degree. Hello, can you see my screen? Hello, can you see my screen?
Yes, sir.
Okay, is it very clear there?
Yes, sir.
That's good. So we move to the next slide. That is the diagrammatic representation of longitude and latitude. So according to definition, I said longitude or lines of longitude or meridian of longitude runs from where? From the North Pole. So the upper part here. So let me write the something there. So here is the North Pole. So the upper part here is the North Pole. So this is the North Pole, while the down part is the South Pole. So this is the South. Now, then the West, West here, which is the line of latitude, and here is the West. So we make use of the four cardinal points. So this is it. So now, line of longitude, you can see the one with the green color. So it moves from the North Pole downward to the South Pole. So all these lines are the lines of what? Longitude. So it moves from the north up to the south, while the latitude runs from west to east or east to west, as the case may be. So it's the horizontal axis, while the longitude is the vertical axis. I think it's clear to you now. Hello? Hello? Is it clear to you? Hello? Hello?
Yes, sir.
So we move to the next slide. So in the next slide, we are going to go to the representation of longitude and latitude. So according to what we have in the diagram, you can see the line of longitude is on the vertical axis, while the lines of latitude is on the horizontal axis. So it means longitude and latitude can be represented using an ordered pair, latitude, longitude. So it means whenever you are given the bracket, the first number you have in the bracket is for the latitude, while the second number is always for the longitude. That is the point A of coordinate S degree north and Y degree west. So this S degrees north represent the latitude, while Y degrees represent the longitude. So this is latitude, longitude. So, but as we have it in the topic, it's longitude and latitude. But if you want to represent it, please, for you to locate a point on the Earth surface, it's going to be latitude, longitude. That is S, Y, just like what we have under Cartesian plane. So it's always X before Y. So the S represents the latitude, while the Y represents the longitude. And we have these two examples too. So point P is on latitude 60 degrees north and longitude 40 degrees west. And question 2 or example 2, Q is of latitude 60 degrees north and longitude 40 degrees east. So this is the representation of longitude and latitude on the Earth surface, or how to locate a point on the Earth surface. So the next one, so we move to the next slide. So the next slide is rules to follow. So when you want to get the angular difference, so there is what we call angular difference or angular distance. At times they call it angular distance or angular difference. But as we have it here, the rules number one says if the two longitudes are on the same side or the same hemisphere, which means they are on the same side of, let's say, the meridian. So if the longitude are on the same side of hemisphere, so that is half of sphere, then the difference in longitude is found by subtracting the smaller longitude from the larger longitude. I don't think, I hope this one is clear to you. Look at the statement. The statement says if two longitudes are on the same side, that is, they are on either west-west or east-east. So if you have two longitudes that fall on the same side of hemisphere is the meridian, that is the vertical line downward. Let me show you from the diagram again. So this line downward, so this vertical line downward, so this is our hemisphere. It divides the sphere into two equal half vertically. So now, if you now have a longitude that fall on the same side of meridian, like this line and this line, so they fall on the same side. So we are going to subtract the smaller longitude from the larger one. But if they fall on different sides of the meridian or of the hemisphere, we are going to add the. So let me go back to the rule. So the rule says if the two longitudes are on the same hemisphere, the difference in longitude, that is the angular difference or angular distance, is found by subtracting the smaller longitude from the larger longitude. And this is also old, and this is also old for what? This is also old for latitude. So the same thing, if you have the same latitude, if you have two latitudes that fall on the same side, so to get the angular difference on the latitude, we are going to subtract the smaller latitude from the bigger latitude. So that is that on the rule number one. Then rule number two says, if the two longitudes are on different hemispheres, that is, one fall on the west and the other fall on the east. So we are going to, that is, one is on the western hemisphere, and the other is on the eastern hemisphere. So the difference in longitude is found by adding the two longitudes in any order. So it can be east plus west or west plus east. That is what we mean by in any order. And this also holds for what? The latitude. That is, if your latitude falls on different side of the equator. So the equator is the line divides the circle into two equal halves horizontally, like this one, this straight line. If you have straight line here, so this is equator. So if you have two latitudes that fall on different sides of equator, we are going to add as well, just like on the longitude. Is that taken now? Hello, is that taken? Hello, is that taken?
Yes, sir.
This rule is very, very important. So we have to so the summary of this is, if you have two longitudes that fall on same side, you subtract. So if it is east east or west west, you are going to subtract the smaller one from the bigger one. But the second one, the same thing holds for what? Latitude. So you can have latitude too that fall on the same side of equator. That is, you have north north or south south. You are going to subtract the smaller one from the bigger one. But if you have two longitudes that are on different sides, you are going to add. So the same thing for latitude on the same side. I mean on different sides. That is north south or south north. You are going to add. So that is that for the rules to follow. Then the next slide says angular distance between the lines of longitude and latitude. So how do we get the angular difference between the line of latitude and longitude? So here I'm going to draw the circle. I will draw the circle. So I will draw the circle, then locate. So let me pick the circle here. So hello, are you still there? Mhm. So I'm trying to circle now. I'm trying to solve this one now. So we are asked to find the angular difference. We are asked to find the angular difference between point A of coordinate 60 degrees north, that is latitude 60 degrees north. I've told you the first number is always for the latitude, while the second number is for the longitude. So 60 degrees north and 40 degrees west, and B is of point 60 degrees north and 40 degrees east. So this question I'm going to use it to explain two things here: how to locate the point on the x-axis and how to get the angular difference. So to do that, solution now. So the first thing is to draw your circle. You draw your sphere. So draw your sphere like this. Hope you can see it. I hope you can see it. Can you see the circle? Can you see the circle, please? Can you see the circle? Hello?
Our Sakina, please respond to the teacher. Talk, please talk.
Respond. So that I
Yes,
know that
sir.
you are following. Okay, that's good. So this is the
Okay.
circle. So what I'm about to do here is to locate the point on the x-axis. So now you have the circle. Then the next thing, I want to have a straight line drawn. So I want to draw a straight line downward. So draw a straight line. So I want to draw a straight line. I'm coming. Let me look at the necessary, the important things to do. I'm coming. I'm coming. Okay. Okay. So we have this. I'm coming. I'm trying to draw this. Okay, let me just use the refill pen. I think this one is not working. This one is not working. So this one is not working. So I will try and draw it. So let me delete it. It's not working. So this one is not working. Let me use the free hand to draw it. So so uh hello.
We can hear you, sir. We can hear you, please.
Okay, okay. I'm trying to use the refill pen and it's not working. This one is not working. I'm coming. I'm coming. Okay. So the next one is to get the angular, find the angular difference between A of coordinate 60 degrees north and 40 degrees west, and B of point of latitude 60 degrees north and 40 degrees east. So to do that, uh, let me pick the pen. Then you draw. I'm unable to draw here. I'm unable to draw here now.
Mr. Dawood,
Yes, sir.
it,
I'm
you
unable
can
to
you
draw.
can you can you can stop the share, then and reshare.
Okay.
Stop the share and come back to the board and reshare. You get my point?
Okay.
Close the board, go out, then log in back to the board and reshare.
Okay. So let me check. Close the share. I'm coming. So the recording will stop. Hello, Mr. Hassan. Hello,
Sir.
Mr. Hassan. Not there. Hello. Okay, let me do it like this first before I don't want to log out so that there won't be problem when I want to log in. So let me check. I don't want to go. So you know what? Let's get the angular difference without the location of the point first. Maybe the next slide will not be like this. So to get the angular difference, where are we going to get our angular difference? We are going to get our angular difference from the longitude, because from the latitude we have 60 degrees north and 60 degrees north from point A and point B. So we cannot get our angular difference where we have the same number and the same cardinal point. So our angular difference is going to be from the longitude. And for you to get the angular difference from the longitude, you check the cardinal point. So the cardinal point of longitude from point A is west, while the second one is east. So since they fall on different sides, so west and east, they are not the same. So they fall on different sides of the meridian. So we are going to add. So it's now going to be. So it's now going to be. Now going to be. I can't stay right here. Can't stay right here. I can't stay right here. I'm coming. Okay. Let me try it like this. So angular difference. I'm coming. I'm trying to adjust it so that I'll be able to. So, so the angular difference now. Let me see if I should do it right now. I'm unable to write. So the angular difference will be theta. So angular difference will be theta equals to. So I'm trying to write. I'm coming. Now let me just share it to the. Hello. Hello. Hello.
Yeah.
Now, uh, no, Motiri now. So, Moti Lotele, I've used it. Moti Fishe, can let me just share it to the if you're able to share it with the something. Let me check. Hello?
Hello, we are here.
Hello?
Hello, can you hear us?
I can hear you, sir. I'm trying to. I'm coming. I want to share it on whiteboard. Maybe it will work on whiteboard. So that maybe I'll be able to write it on whiteboard.
Is whiteboard loading now?
It's loading.
Okay, right, sir.
Now, can you see my whiteboard screen?
Right, sir.
Can you see?
Respond to you. Can you see whiteboard, all of you? Awad, Sakina, please respond to him. Can you see his whiteboard?
No, sir.
No.
Yes.
Okay, let me check it again. Let me check it again. Let me check it again. And it was perfectly working before it suddenly stopped. Okay, I'm coming. Let me try and save it. I'm coming. Save as PDF. Save as PDF. So save as PDF. So let me now go to whiteboard. SmartMaths. PDF. Hello. unable to move it to.
Yes.
I'm unable to move it to. Let me check again. I want to move it to the document. Other things around there. So it will be. I'm coming. Hello? Okay. Hello, Mr. Hassan. Hello? I've seen it. Multi, Otishi, Otisho, Otisho. Oh yeah, so I can draw on it now. Yeah. So hello, hello,
Hello, we are with
hello.
you.
Okay, now,
Hello, we are with you.
uh, so I can draw. So I'll use the rough sketch. I've told you I'm going to use this question to answer the location of point and to get the angular difference. So let me just have my rough diagram of a circle. Hope you can see my board. Can you see my board? Can you
Dear
see my
student, let's
circle?
try to respond to him, please.
Okay. So this is the circle. Or X surface. Then we have the north here. Then we have the south pole here. We have the south. Then we have the west. Then we have the east. We have the east. Then the point is point A of latitude 60 degrees north. So we come to the north side of the. So far it is not latitude is 0 degree. We not put it at the center. So it's more from west to east. So we just have a line parallel to the what? Equator. Then you now draw latitude 60 degrees north. So this is 60 degrees. So this is 60 degrees north. So you label it as 60 degrees north, 60 degrees north, 60 degrees north. Then 40 degrees west. You come to the west side of the meridian. West side of the meridian. Let me print this. West side of the meridian. Then you print this. Let me print this again. Okay. So west side of the meridian. West side of the meridian. So you draw a line downward from the north pole. Mind you, it must be from the north pole. So you have it like this. So this is 60 degrees. This is 60 degrees north. This is 40 degrees west. Sorry. So 40 degrees west. 40 degrees west. Then the point of intersection of latitude and longitude is point A. So this point here is point A. You label it as A. So you label it as point A. Then you come to the point B, latitude 60 degrees north, so which means they possess the same latitude. You will now redraw the latitude, then 40 degrees east, then you come to the east side of the meridian to draw 40 degrees east. So this is it. Then you label it as 40 degrees east. 40 degrees east. 40 degrees east. 40 degrees east. So now, this is how to locate a point on the earth surface. So then, the point of intersection of latitude and longitude is point B. So this point is point B. This point B. Then to get the angular difference, we have theta. Theta equals to. So I've told you we are getting our angular difference from the longitude, because on the latitude we have 60 degrees north for point A, 60 degrees north from point B, so we cannot get it. So the rules of longitude is of angular difference is when they fall on different side of the meridian or on the equator, we are going to add. So west, east, we are going to add. So it's going to be 40 degrees plus 40 degrees plus 40 degrees. So which is equals to 80 degrees. So the angular difference is 80 degrees. So this is angular difference of the first question. That is theta equals to 40 degrees plus 40 degrees. That is 80 degrees. So that's how to get the angular difference and how to locate a point on the Earth's surface. Then the next slide, that's the next slide, slide 7. So we have find the angular difference between 60 degrees north and 20 degrees west, and T of 40 degrees north and 20 degrees west. So we are going to get the angular difference from the what here? From the latitude, sorry. So let me pick the diagram. Maybe I should be able to pick it now. So that, let me check if it will not scatter this time. So I think picking of diagram it will be better. So picking of circle, it will be better than drawing. So drawing is not that accurate. So it's rough. So let me check. Let me try and insert. I can't find the insert there. Okay, I've seen draw. Yes. Then pick the circle. So I'll pick circle. So let me draw the circle. So here is the circle. I pray it to not scatter this time around. Then we now draw. So let me go to draw. Then we have this. So find the angular difference between what? Between point S of 60 degrees north, that is the latitude, and 20 degrees west, longitude, and T of latitude 40 degrees north. So let me draw the cardinal point. So we have the sphere already. So the cardinal point is this. So let me redraw this. So let me redraw it to have a perfect vertical line downward. So this is it. Then for the second one, the latitude line, equator, we have this. And here is the North Pole. And here is the South Pole. Hello, hope you can see it now. Then here is the West. And here is the East. Then locate 60 degrees north. 60 degrees north. So we are going to draw our, so 60 degrees north. So if you check point T2, it's also on the north. So let's draw the 60 degrees north here. Straight line, vertical straight line. Then draw your what? locate your, so locate this. So this is latitude 60 degrees north. So label it 60 degrees north. Hello, hope you can see it. Hello, can you see it? Hello, can you see it? Please respond.
Kindly unmute your mic and respond to him.
What do you say? Okay. So now this is 60 degrees north for point X, then longitude 20 degrees west. So you come to the west side of the meridian and locate your 20 degrees. So this is 20 degrees west, 20 degrees west. So we have this. Then you now label it as 20 degrees, 20 degrees west, 20 degrees west, 20 degrees west. Then the point of intersection of latitude and longitude is point S, point S. So then you go to the point T, 40 degrees north. So it's also on the north, but the main center here is 0 degree. Definitely we are going to get to 40 before 60. So your latitude 40 degrees north will be before 60 degrees south. So it's somewhere here. It's somewhere here. So it's somewhere here because they fall on the same side of the equator. So we now have this. So we have this. We have this. This is 40 degrees north. So this is 60 degrees north. So this is 40 degrees north. Sorry. So this is 40 degrees. 40 degrees. 40 degrees north. So now, the point of intersection of, okay, what's the latitude? 20 degrees, which means they possess the same latitude, the same longitude, sorry. So this is point T. So this is point T. Now, if you want to draw, normally, maybe we are solving this distance along great circle, which is along the equator. So you must take this one to the main center here, and take this one to the main center. Then the point of intersection, that is the space between them, is the angular difference. So this is theta, angular difference here. So this is the angular difference. So you can now see theta, which is the angular difference, equals to, so where are we getting our angular difference from? It will be on the longitude. It will be on the latitude. Because we have the same longitude, so we cannot get our angular difference from the latitude. From the longitude, we are going to get it on the latitude. So since they fall on the same side of the equator, we are going to subtract. So it's going to be 60 minus 40. So 60 minus 40, 60 minus 40 equals to 20 degrees. So the angular difference here is 20 degrees. That's the angular difference. So that is question number 2 on the angular difference and how to locate a point on the earth surface. Then the next slide. So the next slide is on distance along great and small circle. Great circle first before we go for small circle. Let me just explain this. So the distance along great circle. So distance along any of the longitude and distance along the equator only among the latitudes are called the distance along the great circle. So I hope this one is clear. So let me go back to slide 3. So slide 3 says distance along the line of longitude. So you can see longitude always comes from the north up to the south. From the north up to the south. Every longitude always from the north up to the south. So that is distance along the great circle. But on the latitude, it's only the equator that is at the middle of the what? Of the earth surface, which is horizontally. So The distance there along the equator is the distance along the great circle among the latitude. But other ones, they are what? On the small circle. So let me go back to slide 8. So we have distance along great circle. So I've explained this. Distance along any of the longitude and distance along the equator only among the latitude are called the distance along the great circle. And the formula to use is what? So we make use of length of an arc formula. And length of an arc formula is given as theta over 360 degrees multiplied by 2 pi r. So where r is the radius of the earth, which is approximately 6,390 kilometers, then the original value is 6,390 kilometers, but it's approximately equal to 6,400 kilometers. So it's this 6,400 kilometers that normally give us in any given question. So where theta is the angular difference. Theta is the angular difference, and pi equals to 22 over 7. 22 over 7. So that is distance along great circle. So we move to the first example under distance along the great circle. So the question says, find the distance between between turns A of latitude 0 degrees south and longitude 30 degrees west, and turn B 0 degrees south and 60 degrees east. So don't forget the conditions. We are going to have the radius of the earth to be 6,400 kilometers. 6,400 kilometers. That is the radius of the earth. Radius of the earth. So 6,400 kilometers. 6,400 kilometers, and pi is 22. Pi is 22 over 7 equals to 22 over 7. So that is what is normally given. That's the additional information, 22 over 7 to this question. Now, to solve this question, we are going to draw the Earth surface. We draw the Earth surface. Let me pick the those for you. We draw the Earth surface. Draw the Earth surface. So to draw the Earth surface, we have this. So let's now locate the point on the Earth surface. So to locate the point on the Earth surface, we have this, the vertical one, which is the axis of the Earth. Axis of the Earth. So this is very good. Then we have this equator. So this is the equator. Then this is the north. So here is the north, south, west, and east. Then we now draw what? 0 degrees south. So the first number is latitude. So 0 degrees south, it will be somewhere here. So 0 degrees south, it will be, so it is here, 0 degrees south. That is latitude is more from west to east. So 0 degrees south, this is the south side. So this is the south. So this is the south side. So this is 0 degree, 0 degree. So which is on the latitude. Then longitude 30 degrees west. 30 degrees west. So the west side, 30 degrees west. 30 degrees west. So we have this. So which is 30 degrees west. So this is 30 degrees west. Now the point of intersection is point A. So we name this point A. Then the second one, town B, 0 degrees south, they have the same latitude, the different longitude. That's 60 degrees east. 60 degrees east. So east side of the meridian, we come to the east side. of the meridian, we have this. So we have this. So which is 60 degrees east. So 60 degrees east. Now, to now get the distance, okay, we have point B. That is the point of intersection of A and B. I mean of latitude and longitude. So the next thing to do, we have to find the distance between A and B. So distance between A and B is distance along the equator, and distance along the equator, we make use of distance along the great circle formula. And what is distance along great circle formula? You have AB, AB, AB equals to theta all over 360 multiplied by 2 pi r multiplied by 2 pi r. So where r is the radius of the earth, pi is given as 22 over, and the theta is angular difference. So how do we get the angular difference? You have theta equals to, so we get our angular difference from the longitude. So it's going to be different different sides of the longitude we are going to add. So it's going to be 30 plus 60. So 30 plus 60, 30 plus 60 degrees. 30 plus 60, so which is equal to 90 degrees. So 90 degrees is the angular, difference. So now, to now solve this, we are going to substitute all these values into the formula given. So distance AB will now be equal to theta. And what is our theta? 90. That is 90 over 360. So it is 90 over 360. So AB equals to 90 all over 360 multiplied by 2 multiplied by 22 over 7 22 over 7 multiplied by radius of the earth. So radius of the earth is 6,400. 6,400. So 6,400. So if you multiply everything here and divide by the denominator, the answer will be okay, just multiply numerator and reduce to the lowest term and denominator. We have 7,400 divided by 7. 7,400 divided by 7. So from there, 0 cut 0, 9 here 1, 9 here 4, 9 here 4. So 2 here 1, 2 here 2, then 2 here 1, 2 here 11, 11. So 11 multiplied by 6,400 is 70,400. Then divided by 7, we have 10,000, 10,000, and 57, and 57.14 kilometers. 14 kilometers. but it's approximately, the question under this is always in three significant figure. So always in three significant figure. So three significant figure of this will now be equals to 10,000, 10,000, 100, 10,100 kilometers. 100 kilometers. That is the three significant figures. So this is solution to question number 1 under distance along great circle. So I've told you distance along the equator is also the distance along the great circle. That's the only great circle on the latitude. Then let's try another example. So you see after. So to make up the main part of the note that we uncover. So let's move to the next question. Question 2 says find the distance between the point. Find the distance between the point S of latitude 60 degrees north and 20 degrees west, and latitude point T of latitude 40 degrees north and 20 degrees west. So let's try this example. Solution. So we draw the diagram as well. We draw. Hello, hope you are still there. Hope you are still there.
Yes, sir.
Hello. Okay, now. So question number 2 now. Let me insert the circle, the square. So I want the circle. So the circle, so the circle here, or the square. Then I want to pick a line as well. Okay, I have it here. Downward. Then the second one. We have this. Then I'm going to do the labeling later. So let me see if I can still insert some so that the diagram will look more attractive. So we have this. Let me see some curve. Connector. Okay. So now 60 degrees north, 60 degrees north, 60 degrees north. So let's say this is 60 degrees somewhere here. 60 degrees is somewhere here, north. So we have it like this. Okay, straight line first. Then let me redraw this to 60 degrees north. So let me redraw this. Let me use the draw diagram. So 60 degrees north. So 60 degrees north is somewhere here. So I'm going to draw the circle there. Then 20 degrees west. 20 degrees west. So this one must come from the north to the. So I can't. Let me use the free hand to do this. So 60 degrees north. We have this. So this is 60 degrees north. Label it as 60 degrees north. 60 degrees north. Then 20 degrees west. So let me label this north, south, west, and east. So point S is 60 degrees north. We have it here. 20 degrees west. Come to the west side of the meridian. Locate your 20 degrees. So this is 20 degrees west. 20 degrees west. So this is 20 degrees west. So 20 degrees west. Now, this point S, where the main is point X, where the main is point X, point X. So this point. Then, T, 40 degrees north, 40 degrees north. So you take it to the north. I told you we are going to get to 40 before. So we have this. So now, 40 degrees west, we have this. 40 degrees north, sorry. 40 degrees north. So 40 degrees north. So you take it to, so this is the labeling, 40 degrees north. 40 degrees north. Now, and the, okay, where they mean, and 20 degrees west. So which means we already have 20 degrees west again. We don't need to redraw. So the point of intersection is now point T. So this is point T. So this point. So you now take this to the main center because we are calculating along the. So let me use a line so that it will be very neat. So this. So we have this. Then we have this again. Then we have this again. Take it to the center. So this is, then the space between them is the angular difference. So let me draw the map. So we have this. So this space here is the angular difference, and we call it theta. So this is the theta. So this is the theta. So to now get the angular, you can see the S and T is along the vertical axis. So it's vertical, not horizontal. So which is distance along the what? Great circle. So you can now see theta equals to, so we are going to get our angular difference from latitude. We are going to get our angular difference from the latitude, this 60 and 40. And since they are on the same side of the equator, we are going to subtract. So that's why we have 60 minus 40. Because we are subtracting the smaller number from the bigger one, so which is equal to 20 degrees. So we have 20 degrees. So degrees. So don't forget the formula. So distance along the great circle or between S and T now. It will now be ST, distance ST equals to theta all over 360 multiplied by 2 pi big R. Big R. So which is equals to, so what is the theta under consideration now? Theta is 20, that is the angular difference. So 20 all over 360. Let me take that again. Theta over 360, which is 20 over 360, multiplied by 2. Let me take that again. Multiplied by 2, multiplied by 22 over 7, multiplied by 22 over 7. So multiply by radius of the earth is 6,400. So 6,400. So we are going to be making use of radius of the earth to be 6,400. So let's now cut and divide. So let's cut and divide. 20 divided by 20 divided by 20 divided by 360. So 0 cut is 0. Then 2 into 1, 2 in 36, 18. 18. Then 2 again, 2 into 1, 2 in 18, 9. Then we now multiply 22. 22 by 6,400. So 22 times 6,400 equals to 140,800. 140, 800. 140,800 divided by 9 multiplied by 7, that is 63. 63. So which is equals to 140,800 divided by 63. That is 2,000. Let me take that again. That is 2,234. 234.920. 920 or 92. So 0.92. So which is approximately equals to 2,000. So to three significant figures. So it's going to be 2,230 kilometers. 230 kilometers. So this is to three significant figures. So I think this is the second question. Hope it's clear to every one of you. Hello. 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 Is it clear to you?
Yes, sir.
Now. So let's try. If you still have time. So I want us to finish this because of the weekly test question. So let's move to the next slide. So in the next slide, we don't have too much. So it's just like similar question like this. So now, distance along small circle. So distance along small circle. So distance along small circle, we explain it as the analysis is the same as that of the distance from great circle. So the only difference is that the radius r of a small circle is not equal to that of the earth, which is r equals to 6,370 kilometers. So the radius of the small circle r equals to r, that is big R cos x. So how do we get this big R cos x? So please look at this diagram. The first diagram. So we have the earth surface, we have the north, south, the west, and the east. So according to this question, small circle. So the small circle is this circle at the upper part here. That is the one labeled B, BM. So this is the small circle here. That is the latitude. So to now get the radius of this small, so we have the distance from B to M. So distance from B to M is labeled R. So this point is labeled R. Let me take that again. So let me do it properly. So this is small r here. So this small r is the radius of the small circle. While the big radius is here. So the big radius is here as we have it in the second diagram. So distance from B to O is the big radius. That is radius of the Earth. So that brings about the second diagram. So we have BMO. So BM is the small r, which is the radius of the small circle that we are looking for, and the latitude is x degree, which is this. Then the greater one, that is radius of the Earth, is 6,370 kilometers. So we have BO to be 6,000. I mean, capital R. So that explains the small r. At times, you might be able to find the radius of the parallel of latitude. So you are making use of this formula. That is r, small r equals to big R cos x. And what is that x stand for? That is the latitude. Big R is the radius of the Earth, which is 6,370 kilometers. So that is that on the what? On the radius of the small circle. So we move to the next slide. So the next slide says the distance along small circles. So the formula to use now. The distance along small circles or along the parallel of latitude is given as length of an arc. So we make use of length of an arc, but it will be for the small circle. So theta over 360 degree multiplied by 2 pi big R cos x. So we replace this big R from the longitude as big R cos x. So where R is, that is big R is the radius of the Earth, which is 6,000. So I think is 6,000 370 kilometers. 370 kilometers. So which is approximately equals to 6,400 kilometers. And theta, which is the angular distance or angular difference, and pi is 22 over 7. So that is that on the this slide. Then the next one, the example on the parallel of latitude or angle on a small circle. So let's look at this example. So let's look at this example, the sub question on the example as well. So now we are the question: what's the distance from Woomera, that is 31 degrees south and 137 degrees east, to Kagoli, 31 degrees south and 121 degrees east. So along the parallel of latitude. So the next thing to do is to draw the diagram. So let's draw. So let's draw the diagram. I'm coming. So let's draw the diagram. So the diagram, which is the circle. So we have this. Just like what we have been doing, how to locate the point and get the angular difference, then you look for the distance. So that's all. So the next thing, you look for your text. You look for your text. You draw. So draw a downward line, that is particle North Pole, axis of the Earth, North Pole and South Pole. So then the second one, so we have this. Then what are you going to do now? So you locate 30 degrees south, 31 degrees south. So this is abdomen, north. Wait, let me. So we label this north, south, west, and east. So after this example, we call it a day. Now, so 31 degrees south. So 31 degrees south is somewhere here. So this is the south side, which is the latitude. It's more from west to east. So 31. So let me use the other Let me use this line. So 31 degrees south. So now look for your shape, the curve. Let me look for the curve to use. Let me use for the curve to use. The curve to use. The curve to use. So the curve to use. 31 degrees south. So from there, I want to. I didn't get it. So let me just use freehand for this. Freehand for this. So let me use freehand for this. That is 31 degrees south. So 31 degrees south. 31 degrees south. I didn't get this diagram. So 31 degrees south. So this is 31 degrees south. 31 degree south. 31 degrees south. Then 137 degrees east. So 137 degrees east. So this is the east side. So 137 degrees east. So 137, just draw your 137 somewhere here. 137 degrees east. So this is 137 degrees east. 137 degrees east. Then Kaguli, 31 degrees south. So they have the same. Okay, the point of intersection. So that is Womera. So I use W for that. Down, 31 degrees south, the same thing. 121 degrees east. So on the same longitude. So, but we have 121 before 137. So this one will come before. Will come before. Will come before. So this is 31, 121, 121, 121 degrees east. 121 degrees east. 121 degrees east. So the point of intersection is what? Is point K. Point K. So we call this point K. Now, since we are calculating along the latitude, so it will be distance along the small circle. So we are taking this. Let me use this. So we are taking this to the center of the small circle. So like this now, this is the small circle. If you complete this circle, I'm coming. If you complete this, just complete this. Hey, let me take it again. So this is the small circle. So we are taking the point K to the center of the small circle, which is this point. Then point W to the small circle, center of the small circle as well. Then the distance between the space here is what we call the angular difference. So this space in between. So this space here is the what? Angular difference. And we name it theta. So let me bring it out. Don't let me. So let me just label it as angular difference, which is theta. And what is theta? We are getting our theta from the longitude. That is 137, 137, 137 minus 121. So 137 minus 121, I think is 16 degrees. So that is 16 degrees. So angular difference is 16 degrees. So now, since we are calculating along the parallel of latitude or along the small circle, so it's going to be distance KW, KW equals to theta all over 360 all over 360 multiplied by 2 pi 2 pi big R cos x. So cos x. So what is x stand for here? X is the same latitude given in the question. So x, let me put it here. X is, let me take that again. So x is 31 degrees. X equals to 31 degrees. So you now substitute all this, especially, the radius of the earth is still 6,400. Pi is 22 over 7. Then the theta, which is the angular difference, is 16 degrees, and x is 31 degrees. So it's going to be KW equals to theta, that is 16, all over 360 multiplied by 2 multiplied by 22 over 7 multiplied by 6,400, which is the radius of the earth. 6,400 6,400 6,400 then multiplied by cos multiplied by cos 31 degrees. 31 degrees. So we now have, so let's just multiply everything here. So because of our time is fast spent, so which is equal to, so let me multiply everything. You start with cos 31. So cos 31, that is 0.8572. 0.8572. 0.8572 multiplied by 6,400 multiplied by 44, that is 22 times 2, then multiplied by 16. So everything there is 3, 8, 6, 2, 2, 0, 0, 0.32 all over that is 360 multiplied by 7, that is 2520 2520. So which is equal to divided by 2520, that is 1,532 1532.619. or 619. 619. So which is approximately equals to three significant figure, it will be 1,530 kilometers. 530 kilometers. So that is the three significant figure. So the answer is 1,530 kilometers to three significant figure. So that is that on the longitude and latitude. So the only difference now, the one that remains is when you are given more than more than two locations. But you cannot just get all the three locations at the same time. It's either you move from, let's say you are given three locations A, B, C. So it's either you move from A to B, then B to C. So you cannot just jump from A to C directly. So you must first move move from A to B, then B to C. So that is that about the class. So inshallah, we'll continue in the next class. So thank you and God bless, and prepare for the weekly challenge that is from Monday to Thursday. So thank you and God bless. Thank you. Bye for now. Hello. 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 So
Sir.
bye for now. Hello.
Okay, sir.
So thank you. So
Thank you
your
very much.
test tomorrow. You are welcome. Thank you.
Okay, sir.
Now.